Now we came to the third method. So we are talking about the general analysis techniques. There are three of them: classical methods, to any equations, to any unknowns. We're going to write, and then we're going to find out all the elements, current and voltages. And the second one, node voltage method. The third one, actually mesh current method. So in this method, we're going to examine this method through an example. This example is the same example that we use for the node voltage method. So in here we've got three meshes we've got here. So we are going to write Kirchhoff voltage law equations for these meshes in terms of mesh currents. So how are we going to write that? So 10 IC1, these capital bold ICs are the mesh current phasors. So 10 IC1 is the voltage of that 10 ohm resistor. Let's go a bit in detail. 20 is the 20 times IC1 minus IC2 is the 20 ohm resistor voltage. So this is altogether is 20 ohm resistor voltage. How we wrote it? 20 times this resistor current. That resistor current is this current. So there are two loop currents that we have got here, mesh currents here. One of them is IC1, the other one is IC2. Since the IC1 current direction and this element current direction is the same, so the sign of this IC1 is going to be plus. The current of this element direction and this second mesh current direction is opposite to each other. That's why their minus sign comes in front of this second mesh current. So this is IC1 minus IC2 is the current of this resistor times 20 gives you that 20 ohm resistor voltage. So this voltage plus this voltage minus this voltage equal to 0. Since this voltage is this independent source phasors. Since the angle is 0, its phasor is just 10. On the left hand side it was minus 10 because this element current direction is opposite the mesh current direction. On the left hand side it was negative, so we moved it to the right hand side. This sign in front of it becomes plus. Similarly for the second mesh, so direction, since the direction is 20 ohm resistor and this second mesh current direction is opposite, minus of this plus this inductor voltage in terms of mesh currents. This inductor voltage is 10J is the impedance of it. So the impedance of this is 10J, and there is one mesh current passing through this inductor, and the directions are the same. So plus minus IC2, the current of this inductor is. So the current of this inductor multiplied by this impedance, you get the voltage of this inductor. So in here, when you come to this dependent source voltage we are going to write, because these equations that we are writing here is Kirchhoff voltage law equation. Since we've got the voltage of this element, we could use the definition relation of this dependent source. According to the definition relation, this dependent source voltage is equal 5 times E. So I write 5 and then this E. This E is this resistor current. This resistor current is also the same as this loop current, and I've replaced this current with this IC1. So what we wrote here is the Kirchhoff voltage law equation for the second mesh. So if we continue with this third mesh, so we're going to write the opposite of this, and then this impedance, we already said these two are connected in serial. There is an impedance. This impedance voltage is 50 minus 10 j impedance multiplied by IC2. This two elements current is IC2. So in here we've got three IC1, IC2, IC3 unknowns and 3 equations. So we can find out this IC1, IC2 and IC3 from these equations. So you might say that, okay, 3 unknowns through equation a bit difficult. No, it's not difficult. IC1, you can write the IC1 in terms of IC2. So that means if you replace IC1 in those 2 equations, you're going to end up with 2 unknowns, 2 equations, so you can easily solve those equations. No supplementary equation that we used here. In the previous one, we used the supplementary equation, 2 of them. So you've got to pay attention to this. Once you calculate the mesh currents phasors, that you can find all the elements current phasors. From these current phasors, you can get the voltage phasors as well. So from these phasors, we can go to the time domain. So there is no any proto simulation here, so you could do it your own, and then you can check your calculation is true or not. So that is the end of these techniques. So 3 general techniques. Why we said general? Because in these methods we could calculate all the elements current and voltage phasors. That's why it is general. So that's the end of this video.